Welcome to the Freightliner Custom Chassis Senior Design Project. My name is Jonathan Allo and my teammates are Michael, Brigitta, Ian, Connor, and Fabio. The objective of this project is to develop and create a more efficient process that will aid chassis transfer and ultimately increase productivity in the current assembly line. Our specifications include reducing the assembly downtime while maintaining safety across the assembly stations and also reduce the use of the existing chain hoist. For our design, we estimate 3,000 pounds over 40 feet of rollers. We decided to go with stainless steel or galvanized steel depending on price and availability for our rollers. Our frame is going to be a square tubing frame that will either be welded and or bolted. As of right now, the first phase of the project has been completed, which includes design proposal and approval. And we are looking forward to the second stage, which includes the building a scale model and also testing the project. Our key components include an AC gear motor, push button control stations, galvanized steel conveyor rollers, a steel frame, flexible V-belts, side safety rollers, and the pedestal security latch. As far as safety goes, the pedestal security latch is going to secure the chassis onto the conveyor as soon as it gets on the conveyor. The side rollers are used to align the chassis for smooth and straight flow to prevent the chassis from falling on either side of the roller system, and the E-stops are conveniently located no more than 6 feet away along the line. This picture shows a CAD model representation of what the roller system would look like. On here we have the chassis on the roller system as well as the side rollers and also some of the emergency stops. The chassis is going to be moving from left to right in the picture and is going to be loaded onto the pedestals that are yellow at the bottom right of the screen. For our electrical and motor systems, two parallel AC gear motors will be connected to a variable frequency drive that supplies 240 volts to the system. The E-stops will also be connected to the normally closed output relay contact of the variable frequency drive. We will also have the V-belt rollers connected to the motors and the bushings and bushings cores. For the flame deflection, the span is 40 feet and the greatest deflection is seen at the ends, mainly the front where the chassis is loaded. That is why we have the 45-degree angle supports to prevent the frame from bending. And for the rollers, the span is about 3 feet, and the max deflection is the dip in the middle of the roller. That dip is very minuscule. In conclusion, the existing chain hoist system is replaced with a more efficient motorized roller system. Downtime is reduced through direct chassis transfer to the stations that follow, and safety is guaranteed with the side roller systems and also the E-stops and the pedestal security latches that have been installed.